Thank you for this nice public to assist to this room. And this is a very good time to do a presentation because it's just a step after the lunch. So if you go out the round, if you leave the room, please don't make noise because there is people inside sleeping the siesta. So please. Okay, so my name is David, as Perrin said before. And with me is Eduardo Anglada, also known as the boy from the stars. So my role in InterSystems is the sales account manager, but also I am manager for the developer community. We enjoy making webinars and other types of content, funny and interesting. Two things for the same price. So if you need some more information about InterSystems or our technology, we have a nice stand outside with 2 arcade machines and very, very handsome people like Eduardo. So please visit us and share some time with us and tell us about your project. So let's go and start the presentation. I'm going to make a briefly introduction, and after Eduardo is going to perform a demo, and after, if we have time enough, I hope yes, you can make questions, okay? And maybe we have answers, maybe not. Well, InterSystems is a multinational company. We say that we are a creative data technology company, okay? Our core product is InterSystems IRIS. That is a data platform. Data platform is more than a database. You can store, query. Of course, you can manage data inside this platform. And you can integrate in a very easy way this data with any systems, with different APIs. And also, one of the functionalities that we are going to show today is IntegratedML, integrated machine learning. That is a kind of auto-machine learning. That is more or less machine learning for non-data scientists, for normal people. Right? So this is more easy to do. You're going to see in the demo that Eduardo can make predictions models with 2 or 3 sentences. Okay? Well, because we are very good managing data and we are very performant, one of our customers is the European Space Agency. Okay? And they use our technology for managing data, millions and millions of data that are data from the space. I mean, different projects that maybe Eduardo can explain after, okay? And it's because that we know more or less something about stars and space, okay? Well, how many of you know what is an exoplanet? 1, 2, 3, lot of people, okay. Well, an exoplanet is a planet, but is a planet that is beyond our solar system. Maybe it's in another galaxy, you know. How many of you come from another galaxy? 2, 3. I come from Ganymedes. Whew. And everyone is welcome. Okay, okay. Well, we have several methods to discover or to identify exoplanets. The easy one to explain, and is the most used, is the transit method. Every planet, or most every planet, have an orbit around a star, and when spin around the star, the planet passes between the star and you. So the light of the star go down for a very few percentage. That is very sensitive, but you can detect something is happening. Maybe it's not so easy because you have different size of planets and you have several planets doing the same orbits. So finally, the good news is that everything is data. I mean, you are taking some measures of the light intensity on the time, okay? So with this data and more data that we can get, we can make predictive models in order to discover an exoplanet. And why is so interesting? An exoplanet. Because maybe we can find something very similar to Earth, okay? So maybe we can visit another planet and go to your galaxy some time ago. Okay, so let's go to play with data. I'm going to let Eduardo to start demo. And after that, if you have any questions, maybe using this QR, okay, you can make the questions. So let's go. Please, thank you.
Now we are going to see a demo, an example of AutoML using IRIS. As David has already told us, IRIS is a data platform. What do we mean by a data platform? It's the kernel is a database, but on top of it, there are many layers which provide different kinds of functionality: business intelligence, interoperability, analytics, and machine learning. And also, it's a multimodal database. We can store objects directly, documents, key value representation of data, and of course, it's a relational database. In fact, what I'm going to show you here today is an extension of the SQL language. That's the good thing, one of the good things about AutoML. It's really easy to use. You don't have to be a data scientist in order to use it, or you don't have to be an expert. You can, on your own, with your IRIS instance, start learning about your data quite easily. In fact, it's so easy that I'm going to use a Jupyter notebook in order to connect to IRIS. I don't know if you're familiar with Jupyter. This is a notebook which is divided in cells. And in each of these cells, you can have code or some text which will help you, and it will guide us through the notebook. Okay? So this is what we're going to see. First of all, I'm going to use the NASA Kepler catalog. This is an official catalog from NASA, taken from the NASA website, which has all the information regarding the exoplanets. Okay? And in order to do the study, in order to study the data, we're going to use Python. Python is a first-class language for IRIS. It is even embedded in the server, and you can code directly in Python. And in this example, we will be a client to the database, but nowadays it is possible to use Python directly in the server. Okay, we call it embedded Python. This is the standard set of libraries we are going to use: Pandas, NumPy, Matplotlib. They are quite common. In fact, in order to handle the data, we are going to use Pandas data frames. These data frames are a data structure which is really handy because it's really flexible and it will let us do anything we want with the data. This is the function we will use to store the data in the database. So first, we connect to the database. It's a standard connection, user, password, and a namespace. We read the data. I'm using containers. Okay, so the data is in a CSV file, a comma-separated file. So we read it. We see the shape. How does the table look like? We see that the name of the columns is quite complex, and that we have almost 50 columns and 9,500 rows. So first, we are going to rename the columns because we would like to use something more meaningful. and easier to understand. And also pay attention to these 3 columns because they will tell us if the results of our model are good or not. They tell us if the exoplanet has been confirmed using a newer NASA mission test or one of the on-ground facilities, okay? So we are going to codify this information. If the exoplanet has been confirmed, we will use a 2. If it's a candidate, it can be proof that an exoplanet has really exists. We will use a 1. And if it is a false positive, a 0. Okay? So we encode this information, and also we will get rid of several of the columns because they are going to be meaningless for our model and they don't provide any information. So it's handy to drop them. Also, several of the rows have data which is a none or something meaningless. Also, we are going to drop them because if not, the model will fail. It will get confused, okay? So at the end, our data has almost 8,000 rows and 38 columns. So let's take a look at the data. We can create an histogram quite easily. We see that the values are clustered among different values. And also we can compute the correlation matrix. This is a symmetrical matrix which will let us know the correlation between the different columns. The darker the color is, the more correlated the values are, okay? So we see that data is clustered and there are several hot spots where the correlation is important. This will be used by the model and it will help us a lot in the predictions. But as in any kind of a machine learning problem, we have to split the data. Why? Because we want to use some data for training and also some data for validation. Doing this is quite easy with IRIS. We split the table in 2 and we save it in different tables. Of course, we will create a view, for example, but in order to make everything as clear as possible, we will use 2 independent tables, okay? So now, this is where the magic begins. We're going to start using the InterSystems SQL extensions in order to create the models. As you can see, the number of extensions is quite small. We only have a create model with a given name, and we say from which data table we are going to create the model from, okay? And after the model creation, we are going to train it. This is quite a standard. And what happens when we do the training? Several things are done inside IRIS. Several models are created. A linear regression and standard classification problem with using binary trees, and a deep learning model using TensorFlow. So you can see that IRIS is compatible with all the standard libraries which you can use in any machine learning project. But the good thing about IRIS is that you can create a connector and use any solution. For example, we are partners with H2O, our data robot, and you can use them directly using the connector, and your problems, your machine learning problems, can be as complex as you need, okay? And we have access to almost all the standard tools. So once our model is created, the different models are created, IRIS takes a look, studies the results, and it will propose you the best, the one which has the best reproducibility of your data. In order to validate the model, what are we going to do? We are going to use the data which has been reserved for validation. So this is, again, a standard SQL validate model. extension. And we only have to show to the model where the data is. Here we can see the metrics. It computes 4 independent metrics, which are the different errors. In this case, the smaller the better. In this one, the bigger the better. So we can see that the results are good, and most probably our model will create great predictions. So let's study the predictions. What we are going to do is create another table and insert in it the 50 predictions, the first 50 predictions. Of course, you could use any other value here. And just for clarity, I have used 50, but we can do whatever we want, okay? And also remember how we encoded the different possibilities. If the exoplanet was confirmed, we have a 2. If it was a candidate, it has not been possible to confirm its existence, it's a 1. And if it is a false positive, it's a 0. So we can see here the comparison. And in almost all of the exoplanets which has been confirmed, our model says that the exoplanet exists. This is great. And well, there are some errors, of course. This is not magic, and some failures must be expected. And as this is the 50 exoplanets we ask for, okay? So, as you can see, with a few SQL extensions, we were able to create a model. This model can be deployed quite easily. IRIS is being used in many countries around the world, in many different situations, and it makes your life much easier. You can create your models, deploy them, and test them. And also, we have a special tool which will help you monitor the quality of the results. If your model starts to drift, as we have the capability of detecting the problem, it will send you an email or whatever alert that you want, and you will be aware that something is happening and that you have to fix your model. So, as I have shown you, with only 4 SQL extensions, you will be able, once you download from the community the IRIS instance, you will be able to create your own models and be as productive as you want. You can learn a lot of your data, and we hope to see you in the stand. We are next to, almost in the middle of the stands, and if you have any questions, we would like to answer them.